Hello and welcome to this recorded session on trigonometric functions of the measure of an angle. Today we will be exploring some important identities that relate the sine, cosine, and tangent function of an angle. These identities are incredibly useful in many areas of mathematics, physics, and engineering. And we will start by looking at the identities we have proved in the previous sessions. Sine 2a equals 2 sine a cosine a. Look at here, we have the angle is 2a. It's the double of the angle a. So we write sine 2a, this angle, here the double of this angle. And this 2 is constant. So when it comes to sine 4a, it's 2. Sine, take the half of 4a. The half of 4a is 2a. So that is going to be 2 sine 2a cosine 2a here. And cosine 2a is cosine squared a minus sine squared a. And also is equal to 2 cosine squared a minus 1 and 1 minus 2 sine squared a. And tan 2a, here the angle is the double of this angle here. Tan 2a equals 2 tan a over 1 minus tan squared a. And also, we have proved that sine a over 2 equals positive or negative square root of 1 minus cosine a over 2. And cosine a over 2 is positive or negative the square root of 1 plus cosine a over 2. Look at the angle here is a over 2, and this angle is a. So in this case, this angle is the half of this angle. And tan a over 2 is equal to positive or negative the square root of 1 minus cosine a over 1 plus cosine a. As we go through these identities, I encourage you to pause the video and try to answer any questions that come up. After you have had a chance to work through the problem, you can check your solution against mine. By doing so, you will gain a deeper understanding of these fundamental trigonometric functions and how they relate to one another. So let's dive in and explore the world of trigonometry. In this example, we have sine 6x, cosine 6x. And if we check the rule of sine, it's sine 2a equals to, this 2 is constant always. And here sine a, cosine a. So here we have to, missing here to apply the rule. So if it was 2 sine 6x cosine 6x, we will write it as sine and double the angle here, sine 12x, because sine 2a is 2 sine a cosine a. So here we can put 2 here, 2 sine 6x cosine 6x, and multiply by half to make balance between them. So here half times 2 sine 6x cosine 6x. I didn't change something in the question. It's the same because half times 2 is 1. And 2 sine 6x cosine 6x is sine 12x. So that is going to be half of sine 12x. The next question, tan 2a, cosine a multiplied by 1 minus tan squared a. I want to get it in its simplest form. So we can substitute tan 2a, as you know, tan 2a is 1 minus tan squared a, 1 minus tan squared a. Tan 2a is, sorry, it's 2 tan a over 1 minus tan squared a. Multiplied by cotan a, multiplied by 1 minus tan squared A. So we have here at the top, at the bottom, the same expression, 1 minus tan squared A. So one cancel another out. You're left with tan 2 tan A, cotan A. We can write instead of cotan 1 over tan A. So cancel tan A and tan A. We ended up with 2. If cosine C equals 1/3, then cosine 2C equals what? You know, cosine 2C is equal to 2 cosine squared C minus 1. So we can put instead of cosine C 1 over 3 squared minus 1. So it's 2 times 1 over 9 minus 1. 2 times 1 over 9, 2 over 9 minus 1 is equal to negative 7 over 9. That's it. Simplify 2 sine x plus 45 cosine x plus 45. The rule we have studied was 2 sine A cosine A equals sine 2A. And here the angle is x plus 45. The angle here is x plus 45. And here we have 2. So we can write instead of that, it's a sine 2A. Sine 2 multiplied the angle, and the angle is given as x plus 45. So in this case, that's going to be sine 2 times x, it's 2x, and 2 times 45 is 9. So we can write it sine, we can write it instead of 2x plus 90, 90 plus 2x. And you know, sine 90 plus 2x, this angle here lies in the second quadrant. And in the second quadrant, sine is positive. And 90 changes sine into cosine. So that is going to be equal to cosine 2x. Cosec squared x multiplied by 1 minus cosine 2x. Cosine 2x is equal to 1 minus 2 sine squared x, and cosec squared x is the inverse of sine squared x. So substitute cosine squared x is 1 over sine squared x. Here it's 1 as it minus. Instead of cosine 2x, we are going to write 1 minus 2 sine squared x. Then expand here, this negative times 1 will be negative 1, and negative multiplied by negative 2 sine squared a is 2 positive sine squared x. We have here 1 and minus 1, they are going to be cancelled. So we ended up with 1 over sine squared x multiplied by 2 sine squared x is equal to 2 y, because sine squared x and sine squared x, one cancel another out. Let's go to the next example. We have here 1 minus cosine x over 1 plus cosine x, and I wanna simplify this fraction. So here cosine x, we have here 1, and I wanna eliminate this 1. So we can write instead of cosine x, it's 1 minus 2 sine squared x over 2. Instead of cosine x, I wrote 1 minus 2 sine squared, and take the half of the angle. The angle here is x. So take the half of the angle, it's x over 2. Over. Here we have 1 plus. And also I want to get rid of this 1 here in the denominator. So we can write instead of cosine x, we can write instead of that, it's a 2 cosine squared, take the half of the angle x over 2. It's a 2 cosine squared x over 2 and minus 1. Okay. Expand this negative here, so negative times 1 is negative 1, so it's 1 minus 1. And negative times negative 2 sine squared x, it's plus 2 sine squared x over 2. All divided by, here we have 1 and minus 1, so cancel them. You are left with 2 cosine squared x over 2. And also at the top we have 1 and minus 1, so cancel them. So we reach to 2 sine squared x over 2 over 2 cosine squared x over 2. Cancel 2 and 2. And you know that sine divided by cosine is tan, but we have here power of 2 and power of 2, so write it as tan to the power of 2 and take the angle as it's x over 2. So we ended up with tan squared x over 2. The next one, b minus 2a equals 180 and 10a equals half. I want to get 10b. So from this equation, we can get the value of the angle b, because b minus 2a equals 180. So b equals 180 plus 2a. So if you want to get 10b, it's also the same value as tan 180 plus 2a, because they are equal. And 180 plus 2a, the angle lies in the third quadrant. And 10 in the third quadrant is positive. So we can write it as tan 2a. And tan 2a, as you know, is equal to 10a over 1 minus tan squared a. So it's 2 multiplied by 10a, 2 by half, over 1 minus half squared. So it's 1 over 1 minus 1 over 4 equals 3 over 4 is equal to 4 over 3. The next example. If A, B, C are measures of angles of triangle ABC, and we are given that 10C is 3 over 4, and the required is to find sine A plus B over 2. Because ABC is a triangle, so the sum of the angles is equal to 180. So angle A plus B equals 180 minus C. If we look at this angle here, we need to find it's A plus B over 2. So divide by 2 both sides. So the angle A plus B over 2 is equal to 180 divided by 2, it's 90, minus C over 2. I want to get sine A plus B over 2. So it will be the same as sine 90 minus C over 2. And 90 minus C over 2 lies in the first quadrant, and 90 changes sine into cosine. So we need to find the cosine C over 2. Okay, that we want to find. We want to find cosine C over 2, because cosine C over 2 is the same as sine A plus B over 2. We have 10C is 3 over 4. If we looked at the angle, it's a C, and the angle we want to find is C over 2. So we're going to use the rules of the double of the angle, which is 10C. 10C is equal to what? Is equal to 10, and take the half of the angle, C over 2. All divided by 1 minus 10 squared, take the half of the angle, C over 2. So we can, to save a lot of writing and save a lot of time, we can write, instead of 10C over 2, we can write it as X. 10C over 2, we can substitute it as X. So 10C is given as 3 over 4 equals 10C over 2, it's 2X over 1 minus 10 squared C over 2, it's 1 minus X squared. Do cross multiplying. So 8X is equal to 3 times 1, 3, minus 3X squared. Move all of them to the next side and find the solution of the quadratic equation. It will be 3X squared plus 8x minus 3 is equal to 0. Then factorize. It's 3x and here x. Negative 3, we write here plus 3, and here negative 1. Okay, equals 0. Then what is the value of x? X here is equal to 1 over 3, and x here equals negative 3. And because the angles here, it's tan c over 2, the angle here is acute angle, so this value is refused. So we will deal with x as 1 over 3. So tan c over 2, tan c over 2, the angle is 1/3. So let's draw the triangle here. And let's suppose that this angle is c over 2. This angle here is c over 2. Tan is the opposite over adjacent, so here it's 1 and the adjacent 3. How can we find the hypotenuse? By using Pythagoras, it's root 10. So we can find the cosine c over 2. Cosine is the adjacent over the hypotenuse is 3 over square root of 10. That's it. Without using the calculator, find the value of 1 minus tan squared 15 over 1 plus tan squared 15. It's 1 minus tan is sine squared 15 over cosine squared 15 over 1 plus tan squared 15, it's sine squared 15 over cosine squared 15. Multiply the top and the bottom by cosine squared 15 here, and here cosine squared 15. So you will find here after multiplying, it's cosine squared 15 minus sine squared 15 over. Here it's cosine squared 15 plus sine squared 15. Sine squared x plus cosine squared x equals 1. So at the bottom we have here 1. And this rule we have studied, cosine squared 15 minus sine squared 15. This is the rule of cosine 2a. So that is going to be cosine, take the double of the angle, cosine 30. And cosine 30 is given as root 3 over 2 divided by 1. So it's root 3 over 2. Remember, don't hesitate to reach out to me if you have any questions or need further clarification, further or need further clarification or need further clarification. I hope you enjoyed this session. See you in the coming episodes. Goodbye.